Okay, I'd like to introduce Paul Wiedemeyer, PhD, and KE5LKY. I don't know which one holds higher status.
The second.
Okay. Comparing 2-meter packet radio data unicast and multicast. Take it away.
Good morning. Before I begin, I'd like to thank the folks from TAPR for allowing me to speak with you today. It's always a thrill to come back to these conferences. I'd also like to thank ARRL for co-hosting or sponsoring this with TAPR. I'd certainly like to thank Kermit and the local Chicago folks for putting on this great conference, and also Gary and the Arvin folks for videotaping this. So if you haven't seen those videos, please, talk to Gary and look at those because they're great. I spent several hours last spring looking at those. I'm going to talk to you today about some research we've been doing at the university that I'm at, looking at primarily multicast and unicast over packet radio. Usually when you look at research, it's like, okay, I've been doing some of this. In fact, last year I spoke about UDPcast as a tool that you could use. And I've been doing a lot more work with that, and that's the crux of this discussion. But then you always step back and say, all right, well, who's going to really use this and why will they use it? It's always, I tell my students, who's going to really care about what you're doing and why should they use it? So I step back and say, all right, well, like John, I have an interest in e-com. And so for me, it's always been, well, how can I improve on the tools that are currently used or provide additional tools that you as the e-com providers or e-com folks would use? So you come up with a scenario and say, all right, well, we do provide this type of service to the local community. And, being a parent myself, I've got 2 children. This would be devastating for me, or to know that my sons, I have 2 sons, would be lost, or in my case, missing. And so this really kind of struck home with me. In the duration of this, then, if this were to occur, certainly in the paper I described it, you'd have some sort of controlled type of net, and the information about this situation then would be disseminated. So here's a description, and it's a description of my son when he was 3. He's 8 now. And so you have that, and then of course, now I'm supposed to say, all right, well, everybody now knows and can see who my son is in your mind's eye. And the reality of it is, well, maybe you do. Maybe well, if you've seen the paper, then you know what my son looks like. But if you haven't seen the paper, then you have an idea of what my son looks like. Well, that's my oldest when he was 3. He's 8 now. And it's just a random picture I chose. Mom takes tons of pictures, so I have lots of pictures to choose from, and that's one that I chose. It could be any child, but based on the description, is that what you get? And I would probably be hard-pressed to say, given a description of a child I've not seen, I may either yes or no come to that. And so this is kind of the motivation for this type of research we've been doing. Well, obviously, you look at an oral or a written description, and it can be ambiguous because the English language is ambiguous. So, picture's worth 1,000 words. Let's transmit an image along with the description to better drive home the fact that this is the child we're looking for. And again, I bring this as the catalyst for this, but this could be anything. We're just talking digital data in general, but I always go back to imagery, whether it's a child or something else. Obviously, then, we need each site that's participating in this network. Again, if we've set this network up, they have to have a packet station. Obviously, they'd have voice communication also. In a typical environment, or at least the one that's in the way I envision it or see it in my area, is that if a network is set up, and if we were to transmit data, and I hypothesize in the paper, so let's assume we have a 4-node network. It could be more, it could be less. But I just drove to a 4-site network. And if the child was reported missing or is lost, and it's at site 1 where this is initiated, then net control would specify, all right, we're going to send this, send the oral description, the written description, or the image from that site. So Again, in this case, if site 1 has that image, then it has to send it once, send it twice, send it 3 times. Now, there are variations where, well, if net control gets the first image, then it could send to site 2, and then site 1 just sends to site 3. So there wouldn't be, truthfully in this case, 3 file transmissions. And that could be debated, but this is the scenario that I'm working with. So we have 3 file transmissions, and truthfully, that's Unicast, and that's an example of types of software that we would currently use to do that. On the converse, and again, this gets back to the paper I had discussed last year, which is a tool that I'm using, which is Unicast. The better solution would be to just send it all at once, right? And again, we call this Multicast. And the tool that I've been using and then had discussed last year was UDPcast. So this year's paper, or this discussion then, is basically what are my results on that? Because I had introduced the tool, I had used it a little bit, but I wanted to do a little bit more research and say, all right, how can I use this and compare it against something else? For example, just a regular Unicast software development or software tool like FTP. So that's the reason for the paper. And the data that I have shows that for the most part, UDPcast will perform better than, in this case, I was using pure FTP, but it could be any FTP client-server software that you use. And that, I would advocate, argue is a strong word, but, when you're writing papers, well, we argue this. I would advocate then that the radio community should do that. And that's, I think, easier said than done. There's still a lot of work I need to do with this, or at least packaging it and making it easier for the community to use. The discussion for this topic then pretty much follows straightforward with regards to the paper itself and the chapters. I spent a lot of time last year kind of describing what we had. I've got, for this research, I had 2 as much identically configured as possible. This is what you see here. I've got several of these Dell Optiplexes that are just, trickle-down effect, and they're sitting in my lab now. Running Fedora Core 8. I've got them configured with AX25. We're using 44.128.2 experimental addresses from the amateur packet radio. They have IP. Those are the IP addresses. Our local packet area, frequency is 145.010. And I've got 271s, I got KPC3 pluses, and West Mountain Radio, and then Astrons. That's really immaterial, but that's the setup that I've gotten. And I've got 2 of those at school, and that's what I had used for this research. Actually, I have a 3rd one at home, but it wasn't... I would have liked to use the 3rd one at home, but the powers that be in May decided that they were going to shut down my building. And by shut down, I mean they powered off, no air conditioning. So I had to scramble. They moved I moved all my radios to another building, and I couldn't actually get connected to the stuff that I had at home that was working. So I spent 4 weeks trying to get everything set back up, and then maybe 2 weeks or 3 weeks actually getting any data. UDPcast, again, that was the primary focus of last year's paper. That's the website for it. If you want a lot more detail about UDPcast, I refer you to the paper of last year. But really, the thing that I like about it is there's no server that's required. Any client, any computer that has this software installed on it, and again, I'm using Fedora Core 8, it's a readily available package through the management tool. You can download that and install it quickly using Fedora, as is pure FTP, which I'm also using. It does run under Linux, Microsoft Windows XP, although I have not tried that. That's, again, on a to-do list. But the thing that I do like about it is that any computer can send a multicast piece of data and receive also. So they can send that piece of data in one instance and then become a receiver, a multicast receiver in another instance. That was in last year's paper. It's in this year's paper. If you're going to receive, it's a command line oriented interface. You set that up, you type this in. File to receive is just the local file that you're going to call that. No synchronization. This is a non-synchronized communication. And the interface in this case would be local AO or AXO or AX0 or AX1, depending upon how many AX25 interfaces you have. I only have one, so it would be AX0. This is the sender. The sender command is a little more complex. Again, that's the name of the file to send. That's the same as the interface on the receiver, so they're using the same. This computer probably had an AX0. Block size, how big of blocks do you wish to send? Asynchronous, it's an asynchronous communication. This is interesting. I'll talk about that here on a couple of the slides, but this is forward error correction. And another thing I like about UDP-Cast is you can increase or decrease the amount of forward error correction you want to add to your transmission. So if you've got a fairly clean line, you can dial down the FEC. If you have a fairly noisy line, you can actually increase that. Maximum bit rate, kind of define, all right, well, if I'm using a 1200-bit packet, I'll set that at 1200 bits, although that can be adjusted, and we found some variation there. I have a capability of dealing with a log file. I'll explain that on another slide shortly. And then bandwidth period, I'll explain that also, because these two kind of go together. The amount of FEC that UDP-Cast, and this is a little bit different from last year's discussion, how much FEC can you add? I kind of glossed on that a little bit, said refer to the paper. I spend a little more time in this paper discussing the FEC because that was one of the things I wanted to look at this past year is how much FEC can I add to a transmission based on certain file sizes and link configurations. The FEC that you add based on UDP-Cast is based on the file size, the block size, and then these three other variables that are defined within UDP-Cast, and one's called interleave, one's called redundancy, and the other's called stripe size. I always just call them IRS, which maybe not as a good connotation, but that's how I remember it, and that's actually how they're defined. In fact, if you go back, there it is. This is the standard way of defining FEC. It's the I component, which is the interleave. Now, the interleave, let me hold that thought. The IRS, the interleave, the redundancy, and the stripe size. So the interleave is the number of stripes. So what happens here is you'll have a file of whatever certain size, and it will be divided and transmitted into what are called slices. UDP-Cast divides everything into slices. Well, the size of the slice is actually a product of, in this case, the interleave, which is how many stripes each slice will be divided into. So you'll have a slice, the slice will be divided into stripes, and then each stripe will have a specific size. Now, as you're transmitting pieces of data to deal with the fact that something might be corrupt, is that individual pieces of data will not fall all in the same stripe. They'll fall across multiple slices. So how many slices you have is dependent upon the interleave, how many stripes within a slice, and each piece of data then will be interleaved across these stripes. And then, of course, how big those slices are in bytes. So really, the two drivers for the slice size is this interleave, how many stripes, and how big each stripe is. That's the product of those two. Now, for each stripe, then, you can define how much redundancy. How many additional stripes do I have to add to, or how many blocks do I have to add to the additional stripe to add this redundancy, which is in the forward error correction. So these three here really drive the slice size. The other one is this block. How many block or bytes are in each of your blocks that you're going to transmit? And that goes back to this. Now, I always I've circled this last year, I circled this again this year in the direct. Each of these have a double dash as the predecessor to the command. This one has a single. I don't know why. I just really have not figured that out, and I haven't had time to figure that out. But I just make note, if you're going to use that, that's a single dash. UDP-Cast then places certain requirements or restrictions. For me, this isn't a restriction, this was a definition. I'm using 256 byte blocks, and that's coming from the fact that I'm using the KPC3 pluses, so I'm setting the TNC pack length to 0, which is 256. The interleave that you use, number of stripes in a slice has to be less than 8. I mean, that's defined within UDP-Cast. The stripe size has to be less than 128 blocks. So now I'm putting these requirements on that's going to dictate the types of data that I can start sending. Files are divided into one or more slices. The size of the slice is the product of the interleave and the stripe size in blocks. There is a requirement on the slice size. I have to be bigger than 16 blocks or greater than or equal to 16 blocks, but less than a 1024. All right, well, this is a driver for me. That's the minimum. This is going to be interesting here. These two combined is actually going to define the smallest file that I can send, which gives me my minimum file size. So given those two, the 256 block and the fact that I've got 16 blocks as the smallest slice size, then that gives me a 4K file size as a minimum that I could transmit using, this 256 block byte size that I've chosen based on my TNC. So given that, knowing that 4K was my smallest file size, and that doesn't seem like a lot, I started going from there. Well, computer scientists, we like powers of 2. So 4, 16, 8. I did monkey around with the file sizes a little larger, but again, at 1200 baud, you're not going to be sending tremendous amounts of data very quickly. And, even though in my area our local packet traffic is minimal, I mean, if you hear anything on the packet channel, it's like, oh, what's going on? I still wanted to be nice, and I thought, well, I'm really sucking up a lot of bandwidth here at 10 minutes. But my Elmer's like, don't worry about it. So I capped it off at 16 just to see how things would work, and then of course I went Midland and did the 8 kilobyte file. To conduct the research then with UDPcast, I had to determine what variations of those I's and R's and S's I wanted to use, what configurations would allow me to transmit or I wanted to use. And so I came to these 5 based on the choice of block size and the restrictions UDPcast provided me or gave to me with regards to the interleave and the stripe size. So I chose these 5 here, and I could have chosen a different one, but this configuration here, this 1/16, interleaves of 1 redundancy, and 16 as the stripe size. This 1/16 gives me 6.5% redundancy, and then 16/16, that's redundancy versus stripe size, that's 16 to 16, that's 100% redundancy. I could have chosen some other ones, but I like the fact that in this configuration, I was only getting maybe 6.25% redundancy with the transmission, all the way to 100%. I could have chosen other ones, but I wouldn't have been able to get this lowest FEC size. So I transmitted these files 5 times using these different interleaves, and this is what I end up. This is the table that comes from the paper itself. There's several other tables in there, but this is the one I wanted to focus on. 4K file, 256 block. Here are the different interleaves, redundancies, and stripe sizes that I used. The number of blocks then that are transmitted for a 4K file then is 16, because again, if I take 4K divided by 256, I'm going to get 16 blocks. And so because I'm using a stripe size of 16, I have 16 size blocks that I'm transmitting. I only have 1 slice for this transmission. So for a 4K file, I'm only transmitting 1 slice. There are 16 blocks in them. With the redundancies then, 1, 2, 4, 8, and 6, that corresponds to a 6%, 12%, 25%, 50%, or 100% redundancy. When you compute that then based on the original file size, 6% is 256 bytes, all the way up to 100% of the 4K file is 4K itself. Which means if I'm using a 50% redundancy during the transmission of this 4K file, I'm really transmitting, 6144 bytes. That's the additional FEC that was added. 50% of the original file is attributed to FEC. So even though I'm saying I'm transmitting a 4K file, I'm really transmitting 6100 bytes roughly. All right. And so it increases. And again, the thing I like about UDPcast is I can dial down or dial up the FEC depending upon what I see in my network. Did the same thing for an 8K file. Again, at 100%, I'm basically transmitting 2 8K byte or blocks, or 16 kilobytes worth of data. If I dial it down to 6%, it's a little over 8,700 bytes. Same thing for 16. Obviously, as I increase 100%, I'm basically transmitting twice what the original file size was at 64 or 6.5 or 6.25% FEC, I've got about 1,700 bytes. UDPcast is a synchronous tool. This is just the nature of the beast. The sender and the receiver, because this is asynchronous, the sender doesn't really know. Well, when they enter into it, they actually enter an agreement. Yes, I'm going to communicate. The receiver says, I want to receive this data. The sender says, all right, fine, here it comes. And at that point, then it just starts flowing through the wires at this point. But there's really no communication between the sender and the receiver after the communication is started. So there's really no way for the sender to know, all right, well, with regards to ACK, I'm not getting anything back. So I don't really know how long this transfer occurs. What's interesting, and I mentioned this last year, is that the UDPcast sender will also record what they think is an instantaneous bandwidth with regards to the transmission. And that's where that log file component comes into play with regards to the command line. And that bandwidth period command line also, you can define how many times the sender will actually start recording instantaneous bandwidths in the log file. So I think during the transmissions I was setting that to about 5 seconds. And so during a duration I'd get so many instantaneous bandwidths recorded in this log file. But they're still not transmission times. All right. Well, there's an algorithm or an equation in the paper that I introduced last year, and it's back again because I need to compute transmission times using instantaneous bandwidths. So again, I was transmitting each of the three files 5 times using the IRS, interleave, redundancy, stripe size configurations. I'm pushing the files to the receivers. I record the instantaneous bandwidths for each one of those file transfers. I stuck it into a spreadsheet. And from there, then, I have the instantaneous bandwidths. Well, then I average those bandwidths. And using those average instantaneous bandwidths, then I calculate, using the equation that's in the paper, transmission time. All right. So that was how we captured data and configured the data for the UDP. Well, the pure FTP, there we go. Pure FTP, it's just a server client software for Linux, Unix. There's the website. You can learn more about it there. Runs under Linux, Unix, and Microsoft Windows, except for I haven't done it under the Windows side. I've still stuck with the Unix, Linux side. When you install the server or the software, you can just use the client alone, and you can connect to other FTP servers with the client if you want. I set it up so both of the Unix boxes that I was using both had FTP servers on them. They had the same types of files, the same 4 kilobyte file, 16 kilobyte file, 8 kilobyte file. And so I could push and pull. I could put and get from both sides if I wanted to. So I set the servers up on both machines to do that, had the identically configured servers there. Pure FTP versus another pure FTP server client software. I selected it primarily just because it was easy to install on the Fedora core. I mean, again, it's a standard package you can download using the administration tool. FTP is synchronous. The client and server are communicating back and forth using acknowledgments. The sender then is able to determine what the file transmission time is. So I didn't have any problem with trying to have to calculate transmission time. I could generate that. I already had that. So in this instance then, I'm the client. I'm getting 10 files, 10 of the same files. So I'm getting 10 of the 4 kilobyte files, 10 of the 8 kilobyte files, 10 of the 16 kilobyte files over a period of days or whenever I was doing these transmissions. And I have the 10 transmission times from each of those. I shove it into this Excel spreadsheet again, and I average those out. So I get an average transmission time from that. And so then I have that I can plot for each of the transmissions then. The files, I started off with this one. Again, I was did the research first, and then it's like, all right, how am I going to pull this to ecom? So I went to this scenario. If I took that original image, I think the one that I showed earlier was of this one. That was a 16 kilobyte file with 512 by 512 pixels. If I degrade that or show it in a smaller file size, it's 4K 256. I mean, it becomes pixelated, but you can still see the image, and that's another branch of research that I've had some students working on. I just, again, multiple irons in the fire, so to speak. I'm not sure what I'm going to do with that. Those images, though, aren't really 4K, and they're not really 8K, and they're not really 16K. It just says that they are. When you look at them, they're slightly less, and I wanted something that was a little more exact. So I said, all right, I'm really interested in just digital data, although the image concept is kind of nice, and this can be used. But I wanted something that was exactly 4K, 8K. So I just created ASCII text files that were exactly of that size. I hand-placed the characters in there. And it's just nonsense characters. I mean, I think there were numbers in that case, but they're exactly that size now. So there are several tables in the paper. Tables are interesting, don't get me wrong, but picture's worth 1,000 words again. What we see here, there's a lot of data plotted on this. So here is, for the different file sizes, 4 kilobyte, 8 kilobyte, 16, and then times, transmission times up here. This is the time it took in seconds. I started off here at the below. So here's a UDP cast at 6.25% redundancy. So if I use the IRS combination 1 by 1/16, that gives me this 6.5. Here are the plots for that at 4 kilobytes, 8 kilobytes, and 16. And so you see these nice little, well, I don't know if they're nice, I guess it could be mean, but these little plots down here kind of clustered together. That's the 2 or 6.5, the 12.5, the 25%, the 50%, and so on. These are the UDP cast transmissions down here. Now these two here that are in the middle, I'm going to save those for a third. I'm going to go up to here. These up here then represent the pure FTP transmissions. Now, this line, this pink one here with triangles, that represents pure FTP, and it says 3 file transmissions. Now, if you recall back at the beginning of this presentation where I had shown the 4 sites, Site 1, Net Control, Site 2, and Site 3, and I said with a unicast, you have 1 file transmission, you have 2 file transmissions, and you have 3 file transmissions. That's what this relates to. So the transmission times that I have for pure FTP are really these right here, these purple green triangles. That's pure FTP for a single file transmission. Then what I did is I extrapolated that and said, all right, well, I have to do this 3 times because I have 3 additional sites. I have, site net control I have to send this to, plus site 2, plus site 3, again, me being site 1. So I just basically doubled the time and then tripled the time. And this is what would it take. So this, if you're in a 4-site configuration and I need to send a 4K file to all 3 sites, this is the additive representation of that. This would be if you're only sending it to 2 sites. Now, this green line, again, is that if I'm only sending to 1 site, maybe I'm only sending to net control, they're the only ones that need to see that, then that's what you'd have. This line here, this blue one, you'll notice mirrors the green one. So this blue line here is a UDP cast, 4 kilobyte file, 8 kilobyte file, and 16 kilobyte file with 100% redundancy. I'm basically sending twice the original image. So if I'm sending a 4K file at this position here, I'm really transmitting 8K of data. 8K, I'm transmitting 16, and 16, I'd be transmitting 32 kilobytes worth of data. I've doubled the file size. There's an interest here because even if I was transmitting that image to one location with UDP or with pure FTP, that's pretty much the same as if I were transmitting it once, twice, or 3 or 4 or n different locations using UDP cast. I took that data then and I said, all right, well, how much faster is UDP cast compared to pure FTP? Because with UDP cast, I can transmit to 1 locale, 2 locales, n locales. And it's the same cost to me. It's just the same time. I just initiate the senders and the receivers and I transmit the data. Well, when UDP cast is using the lowest effect value, I'm getting anywhere between 60 and 80%. I suppose I'm leaning more towards something about 70. And then when I add more FEC, the percentage increase decreases a little bit. These values right here are everything. This line right here is UDP cast with 50% or less. Well, 50% FEC. And I'm still getting better than 20% for UDP cast with 1 file transmission. And this is one file transmission. If I was doing the same information, well, I actually have that. This is one file transmission, so here's your 4K, your AK16. This right here is UDPcast with 100% file transmission compared to a pure FTP with a single file transmission. So me being Site 1 sending to net control only. That's a negative percent fastness. Basically what that means is, and that's why I circle this and put this in the paper, is that truthfully at this point, a 16K file UDPcast is worse than pure FTP. In fact, pure FTP is 24.7% faster than UDPcast in that instance. It's not something that I expected going into this, but it's kind of interesting to see is that if I'm only transmitting the file to one locale, in this case, if it's 16K, and I would expect that it would be the same if it was a larger file, you might as well use pure FTP, even though it's acknowledged protocol. But when things start, when you start transmitting into networks that contain not just two nodes, to 3 nodes, to 4 nodes, as I have, if I have to transmit this file to 2 nodes, then at this point, UDPcast, even if I have 100% redundancy, still outperforms pure FTP, because pure FTP, I have to send a net control and then site number 2. I can do this in one fell swoop with UDPcast, and these are the percentages. And obviously, because pure FTP has to send twice, these values are going to be much larger as far as percent faster. And then, of course, if pure FTP, if I have to transmit this to all 3 sites in this network, again, UDPcast is doing it in one fell swoop, the percentages do increase. And this, truthfully, is I kind of hypothesized that this would happen. And again, the one that I didn't expect was this. I didn't expect this to be just about as equal. So to me, that's kind of interesting as a scientist. Why is that? And I hypothesize about that also in the paper. And I'll talk about that here when I get towards the end. With 100% file redundancy, if you have a situation where you need to transmit this digital imagery to 2 places, so there's at least 3 participating nodes, then my research is showing that at least with these smaller file sizes, and I suspect that would extrapolate out to some larger ones. The question, I just haven't gone, I think I went to 32K for a couple transmissions, but they were very long, and I just didn't want to suck up that much transmission rate. And with UDPcast, when the transmitter is sending, it's always transmitting. And so I had to be a little bit cognizant of, all right, how long am I keyed on? Because you're keyed on for a long time. Those, you put your hand behind the transmitter, it's getting hot. So I didn't want to burn out my transceivers, so I kind of limited that to about 10 minutes, which in this case is a 16K. Now the caveat then is if you're only going to transmit, you only got 2 participating nodes, I expect then that the larger files, pure FTP may actually, at least in the 16K portion, FTP is going to perform as well or better than UDPcast for that scenario. Now, if you have the redundancies down below 50% and less, then still UDPcast performs better. Now, I don't know how that would play out into 32K or 64K files. I don't know. I haven't done that yet. That's, again, I suppose you can put that on my to-do list. But there's a side note that I have to mention, and it'll be on the next slide. If the communication channel is relatively error-free, then I would say in general UDPcast performs better than pure FTP. Now, again, in the paper I had mentioned that the 2 transmitters, the transceivers, were both in one room. They moved me over to the geosciences and threw me in some rock lab. So I had to set this stuff up. The transceivers were not far apart, 15 feet, 20 feet, if most. I think I said 15, or maybe 12 to 15 feet in the paper. So they were in close proximity. I really had intended to do this research this summer and transmit between work and home, which is about 5 miles, which probably be more representative of what you'd see in a situation where you have, providing some sort of communication services for a community. Now, when we were doing these transmissions, there's no local packet. I could tell that there was nothing going on, and even though with Linux I can do an MH or MHERD, and I can tell there's nothing else going on. The receivers are not seeing anything else, so I had a fairly clean channel. One thing to note, pure FTP is at the transport layer is using TCP, which is dealing with retransmission when packet errors occur. Since I didn't have any packet errors, we weren't dealing with any retransmissions at the pure FTP level. But if there were errors, then that's going to increase the transmission time. Now, I suppose one of the things I really had intended to do, and it actually looks very much like what John had done, is that you've got two participating nodes, plus you've got some sort of monitor in the middle. And I think even last year's paper, I had talked about having a transmitter or a receiver, and then somebody to actually start introducing errors. I didn't have that capability readily available, and in fact, like I said, I only had like 2 or 3 weeks to generate some of this data, and I was scrambling to do that. I was lucky to actually get any data at all. UDPcast, conversely, then uses UDP and the forward error correction. Now, if there was competition or congestion in the network, the forward error correction then will be used by the receiver to correct any errors that occur. So if there were packet errors, that really doesn't increase the transmission time because that's what the FEC is for, right? And so if I'm seeing increased packets or seeing congestion or seeing competing traffic in the network, I can dial the FEC up, and hopefully the receiver will be able to interpret that and say, yes, the packet is fine, I don't have to interpret it, or the packet is incorrect, I'll add the FEC and pull back the original message. That single anomaly that I had noticed with regards to UDPcast performing worse than pure FTP for a 16K file at 100% redundancy, I need to look more at that. I need to investigate larger file sizes and some different FEC values. So that is on my plate. I do have, like I said, I have 3 transceivers at 2 meters, the 271s, 271As, the Kenwoods. I also have 3 V71A Kenwoods dual banders. And so some of the stuff I wanted to do this summer was actually start doing multicast over 70 centimeter. And that just didn't come into play because of what happened on my campus. So that is something that either will be done this winter or maybe next summer, depending upon how things play out. I have an inkling to create some sort of mathematical equation that estimates the UDPcast instantaneous bandwidth. And I'm primarily interested in that in maybe estimating and perhaps higher transmission rates than 9600. And my interest there is maybe estimating what a multicast would look at like over a digipeater perhaps, but maybe a digipeater that's much farther away. Tom Clark, one of the AMSAT folks, has got a Geo Eagle proposal, a geosynchronous satellite. And that interests me as far as the concept of doing multicast over something like that. But of course, the platform doesn't exist, so I'm looking into that and using the Geo Eagle as kind of a catalyst for that. Another thing that I'm interested in, and if you're interested in this, please certainly talk to me, is that I can do a lot more multicast. I have a few other things that I'd like to do. What I need to do with this is to kind of put it into a nice package that you folks or the folks in Ecom could use. Now, John and I talked about this a little bit, and he's like, well, you really need to do this on the Windows side, and I agree, but I'm also looking or thinking about doing live CDs so that you could have a CD, install it, do some basic configuration, and be able to do this multicast without having to spend as much, or the time that I've spent. I can make it hopefully a nicer interface that you could just play with this. So if you are interested in something like that, certainly talk to me and say, yeah, sure, I'd be interested, or no. But that's also on my list of things to do. So acknowledgments, the department, and of course the wife who read this stuff, and leave that up there. Questions?
One of the advantages of FTP is that you get an acknowledgement that the file got there correctly.
True.
Your system doesn't have that, so have you introduced any mechanisms so you do know that it got there?
That is an excellent question. And I've talked to folks about that before at last year's conference. I have not thought about how to do that. It's one of those things where, as computer scientists or engineers, we could do this, we could put that in there and do that. But at the same time, I recognize in this type of directed net that you're still going to have verbal in addition to packet. And so my simple answer would be, well, okay, did you get that? Did you get the image? Did the data come to you correctly? And that would be a simple, yeah, I got it. Or if not...
That's again 3 transmissions.
But an oral over a different frequency. Yeah, we could debate that, yeah. There's that, let's tie up the loose ends. Did you really get that image? And if not, we could try the retransmission again. But no, I have thought about that. I just haven't, it's sitting in the back of my mind. It's like, yeah, we could do that. The question then becomes how, and I don't have an answer to that one yet. But it is something that I've been thinking about, and it's a good question. Thank you.
Normally you generate an FTP mechanism based on the error characteristics of the channel. Mm-hmm. And you're using an off-the-shelf system that was, I assume, designed for wired networks, not radio networks.
That is correct.
Error characteristics are very different. Do you have any confidence that your forward error correction has any relevance to the error channel?
I have not done any testing on introducing errors on my own. I mean, that is a component that I had intended to do this year. It just didn't happen because, are we still there? Because of the move that had occurred. But that's certainly an extension of this where I could actually start introducing errors into the stream and then seeing how well the FEC actually works. You're correct in the fact that UDPcasts is primarily for wired environments, and I mentioned in the paper that its primary purpose was for distributing operating system images across a wired environment. The thing that drew me to UDPcast was a statement basically talking about satellite communication using UDPcast. I haven't tried that, but certainly the slow and go packet stuff somewhat resembles that. The other fact was, again, I mentioned that you could have a sender and a receiver both for this. You don't need a dedicated server. And I can dial up or dial down the FEC. But that is certainly something I need to look at, and it's on my list of things to do. So the list keeps getting longer. You know how that goes. Well, again, thank you for your time, and I'm certainly happy to talk to anyone who wants to discuss this. Thank you.
Thank you, Paul.